projects. In this video, we are going to explain about the project title Efficient Local Secret Sharing for Distributed Blockchain Systems. Introduction. The project employs local secret sharing (LSS) to optimize data storage in blockchain systems. LSS reduces storage requirements while enhancing data recovery capabilities, improving the overall efficiency of the system. Traditional blockchain storage methods involve storing complete data or keys in each node, which consumes significant storage space and hampers data recovery processes. LSS addresses these challenges by distributing data intelligently. Blockchain technology is used to secure data by converting it into transactions and generating verification hash codes. Data integrity is ensured through hash code comparisons before adding new transactions. This approach maintains stamp-proof records and enhances data security. Objective. The project's primary objective is to minimize the storage space required within a distributed blockchain system. By doing so, it aims to address the storage-related challenges that are commonly associated with blockchain technology. To achieve this, the project integrates secret sharing techniques, including methods like Shamir's secret sharing. Data is divided into shares, and these shares are distributed across various nodes in the network. This approach significantly elevates the storage burden on individual nodes, promoting efficient storage. The project goes a step further by introducing local secret sharing (LSS) as a solution. LSS is a method that enhances distributed blockchain by combining global data, such as hash codes, with locally stored data like private keys. This segregation of data helps reduce overall storage requirements and improve scalability. Another critical aspect of the project is the enhancement of data recovery processes within a distributed blockchain. In the event of node failures or compromises, the system allows for data recovery by facilitating connections with local peers rather than relying on communication with all nodes. This approach not only improves data recovery efficiency but also reduces communication costs. Requirements. Hardware requirements of the project are processor of 5 and above, RAM of 8 GB and above, ROM of 25 GB and above. Software requirements of the project are Node.js, Python 3.7.0 version, and Visual Studio Community version.
Methodology. To implement this project, we have designed the following modules. The first module is Enter Data. This module is where the user inputs the data they want to store in the blockchain. Users can enter the data they wish to be secured and maintained within the blockchain system. Number of global peers. This is the parameter where user specifies the number of global peers or nodes responsible for storing and managing global data, such as hash codes used for verification. Number of local peers. Users provide the number of local peers or nodes that store and manage local data, which typically includes private keys specific to each node. Run traditional blockchain. This module initiates the process of storing the entered data in a traditional blockchain system. The data is stored on all nodes without secret sharing. This step helps user understand the storage requirements and approach in a traditional blockchain. Run distributed storage blockchain (DSP). In this module, the project simulates the use of distributed storage blockchain (DSP). Data is divided into shares and distributed across multiple nodes, improving storage efficiency. Users can see how data is distributed and recovered using this method. Run distributed storage blockchain with LSS. This module demonstrates the application of local secret sharing (LSS) within a distributed storage blockchain. Data is segregated into global and local components, reducing storage space and enhancing data recovery. This step illustrates the benefits of LSS in terms of storage optimization. Storage comparison graph. After running the different storage methods, the project generates a storage cost comparison graph. This graph visually represents the storage cost associated with each technique, allowing users to compare and understand the efficiency gains achieved with distributed storage blockchain (DSB) and local secret sharing LSS. Blockchain integration. The project harnesses blockchain technology to enhance data security. Data is treated as a series of transactions, and each transaction is assigned a unique verification hash code. This hash code is generated using a cryptographic hash function which serves to safeguard the integrity of the data. It ensures that data remains tamper-proof and unaltered. To efficiently manage these transactions, the project stores them in a KD tree, a data structure known for its effectiveness in storage and retrieval. Before introducing a new transaction into the blockchain, the system validates the old transaction's hash code for data integrity. If the verification process fails, it raises an alarm to signal potential data tampering. To ensure data redundancy and fault tolerance, the project implements distributed storage. It divides the data into shares and employs secret sharing techniques. This separation includes keeping global hash codes distinct from local private keys. This strategic segregation not only reduces storage costs but also localizes data recovery efforts. In the event of node failure or compromise, the system recovers data by connecting to local peers, thus minimizing communication costs. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the main code file. This is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the application. This is the graphical user interface created using Tkinter library in Python. Using this GUI, we will interact with the project. So here we need to enter the data to store in blockchain, and then we need to enter the number of global peer to store hash values, and then we need to enter the local peer to store private keys. So I'm entering the message here. Welcome to blockchain data security. So this message will be encrypted and stored in the blockchain. Now I'm entering the global peer has 3, and this global peer is used to store hash value. And now I'm entering the local peer has 6 to store private key. After entering all these details, click on Run Traditional Blockchain button to store above data in all nodes and then calculate storage space. So here we can see the private key is generated, and this is the encrypted message which is present in the blockchain, and we got the previous and current hash code, and this is the decrypted message which we can read, and we got the traditional blockchain storage which is this much. Now click on Run Distributed Storage Blockchain DSP button to share above data with multiple nodes as secret part instead of whole data. So here we can see we got the original private key which is this much, and we got the shares generated from the private key which is separated by a comma, and each share is stored in each node. And here we can see by combining all shares we are generating the private key again. And here we can see the reconstructed private key which is this, and here we got the previous and current hash code, and this is the encrypted message present in the blockchain, and this is the decrypted message, and here we got the DSP blockchain storage which is this much. Now click on Run Distributed Storage Blockchain with LSS button to share secret hash code in global peer and private keys in local peers, and then calculate storage cost. In above screen also, we will get same output as DSP, but the only difference is instead of storing private and hash code in all nodes, we have stored hash code in global peers and private keys in local nodes. And due to separation of hash code and private keys, the storage space will be reduced, and upon node failure, they can recover data just by connecting with the local neighbors instead of connecting to all nodes, and then we can save communication cost also. Now click on Storage Comparison Graph button. Here on the x-axis, we have the technique name, and on the y-axis, we have the storage cost for each technique. From the graph, we can conclude that DSP with LSS consumes less storage space compared to all other techniques. Now close this graph. The conclusion of the project is, the project effectively showcased a reduction in storage space by implementing distributed blockchain storage with local secret sharing LSS. Instead of storing complete data on every node, data is divided into shares, and these shares are distributed across the network. This approach significantly reduces the storage requirements for individual nodes, making the system more efficient. In this project, hash codes and private keys are stored separately in global and local nodes. This separation enhances data security by reducing the risk associated with traditional centralized storage, where all data is stored uniformly. By segregating data, it becomes more challenging for potential attackers to access both the hash codes and private keys, thereby improving overall data security. The project demonstrated an efficient data recovery mechanism. In the event of data loss due to node failures or other issues, nodes can recover lost data by establishing connections with local peers. This approach minimizes communication costs and ensures that data can be quickly restored, enhancing the overall resilience of the system. Distributed blockchain storage with LSS offers an effective data reconstruction process. Even in scenarios involving node failures or malicious attacks, the system can reconstruct the data from the available shares. This ensures data integrity and availability, which are critical in maintaining the trust and functionality of a blockchain system.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.